Hello and welcome to the video lecture for the engineering graphics. This is Arpan Pandit and this video lecture is about introduction to engineering graphics. In the previous parts we have seen that how we can use the engineering graphics for various purposes. We have seen the introduction of the engineering graphic in terms of the how many numbers of lines are there, line types are there, how the projections are very much important, how we can draw tangent lines. Now GTU have taken so amazing initiative for the betterment of the student that they have collaborated with the Cognifront software. The Cognifront software is a Nasik based company, and with use of that we can have animations for the same. Now in this part of the video lecture we will see various type of projections, how the dimensioning is very much important in all the parameters, as well as we will see the animations for the geometric projections. Now let's have first look. As we talked that we need to have the types of projection, we need to know what are the types of projection. If we see, there are four types of projection. First one is perspective projection, another one is multi-view projection, third one is isometric projection, and fourth one is oblique projection. Now these all projections are different from each other in various manners. In the next part we will see how we can differentiate between these kind of projections. If we see that it is a true perspective projection, when we need to have a brief idea about the total length, then at that part we can use the true perspective projection. As you can see in the picture, the object drawn is in the true perspective look. It looks realistic. It looks like the photograph have been taken and they have some sort of vanishing point where straight line also seems like it's converged lines. Now they can have 1, 2 or 3 vanishing point depending on the how much artists want to work. In this type of perspective projections, you can say a 2D model can also be look like a 3D model, but in the true perspective, objects are far away will be drawn smaller than nearby object, and that's not good idea in any sort of technical drawing. Now let's see over here. If you see that this is the vanishing point, that this would be the ending point of our picture. Till that point, till this vanishing point, we are looking at the projections. If you see that these straight line collide with each other at this vanishing point. If you see the second picture, it have 2 vanishing point, which means that it ends at 2 points. If you see over here on your left side, it's projected over the left. And if you see over your right side, it extended projection towards its right side. Now in the next figure, if you can see that the true perspective is taken for 3 vanishing point on the bottom portion also. Due to this, as you can see, it looks a realistic view. If any drawing have 3 vanishing point, then it looks very realistic. But as you can see that object are far away will be drawn smaller than nearby object. So that's disadvantage for us as we are talking about the technical drawings. Few more perspective view projections. If you see these projections, you can see maximum number of the object in the drawing. Over here you can have a brief LAN idea for the 2 vanishing point. As you can see that this picture have been captured with the two vanishing point on the left side and on the right side. It can give you brief idea that how it differs from each other. Over here you can see that this projection have been taken with the three vanishing point, and over here it's only one vanishing point, so it looks clear. But in this, if we have more vanishing point, then it can be much detailed. Now that you have seen some nice perspective drawings, what we use about them? We hardly ever use perspective projections when doing any sort of technical drawing. If we talk about any sort of perspective projections, it basically for the representational purpose only. If these kind of drawing we want to show to a person who is a non-technical guy, so over there we can use those kind of drawing. But if we are talking about any sort of technicality, we hardly use this kind of projection. One more thing, they are too much work and they don't show all the details that you may need to show if you are doing any sort of technical terms out of it. Also they distort both angles and the dimension. As you seen in the projections that far object will be smaller than the nearer object, so that's a disadvantage of the same. So we can say that these kind of projection we can leave for the art class. It's not our cup of tea. Now this is something which can be our cup of tea. Now these are the isometric projection. It is a simulated perspective drawing style. We have set our vanishing point at some sort of angle. Isometric drawing look at first like perspective projections. You may feel that it is a perspective drawing only, but the line do not converge, they do not merge with itself, they don't have any sort of vanishing point, and the distance object are same size as nearby. It shows the perfect dimensions with the scale. Now if you talk about the isometric projections, we have set the 30 degree on the each side of these drawings. Now let's have a look at the figure first of all. As you can see over here, the total sum would be 90 degrees. We have set the 30 degree over here, but if you see that the total angle is set at the 90 degree, which means that we have simulated this drawing. Over here also on the uppermost side, if you see on the uppermost side, the angle would be maximum 120 degree, which means that you need to set your protector at the 90 degree because it's 30 degree already. If you subtract 120 minus 30, it comes around 90 degrees. Some more isometric projections. Now if you see these kind of isometric projections, if you look over here, then these kind of isometric projection, if you see the red lines over here, you can see that these lines do not converge with each other. It goes into the straight line only. It do not intersect with each other at some sort of point. One more thing, as you can see over here in the blue line, the projection is set at the 90 degree. Total would be 90 degree. Now when we are talking about the mating common surfaces, as you can see over here, the two rectangles are mating with each other at one surface denoted with the dots. Over here triangle, two triangle, right angle triangle are matching with each other represented with the dotted points. Now these kind of thing do not use. If we say line contact, if you see, it have only line contact. With the two rectangle, you have only line contact. In the rectangle and the triangle, you have only line contact. Over there also, you might not use this isometric drawings. But where we can use this kind of drawing? We can use these kind of drawing where we need to add the shape or we need to subtract the shape. As you can see over here, in the rectangle we have added a triangle, so it looks better and we can use this kind of thing. If you see over here, on the bigger square we have added a smaller square on the top surface. It says that it is a addition of the material. Now subtraction of the material. From this square, if you see that this triangle have been deducted. Over here, from this bigger square, the smaller square have been subtracted. Now some of the workbook classifies that isometric drawings are perspective drawing, but they are perspective drawing, but they are not true perspective drawing. They are simulated perspective drawing. Now if you say that simulated, which means that these kind of isometric projections have been created with the 30-degree angle. If you see that any of the drawing you want to make in the 3D on your paper, then you need to draw using the isometric projections. In the previous part of your curriculum, you will see how you can draw isometric projections with use of all the equipment used, and the benefits of the drawing isometric projections are vast. With use of the isometric projections, you can represent the model, actual model. If you see that if you want to represent any sort of model, but you don't want to give much technical terms to any sort of drawing, then isometric projection would be the ideal projection to use. Now if we see oblique projections, they are similar to isometric projection, but there is some sort of difference in the same. If you see this drawing, it has been simulated. This side is accurate 90 degree, but if you see, these lines are not at 90 degree at all. The oblique projection, the side of the object facing you drawn square and the accurate, but side not facing you are distorted, which means that if you want to give any sort of extra added extension to any projection, then these kind of oblique projections can be used. Now let me give you one example, that if you want to draw oblique projections for a marker, then how you can draw this? You can have a simple square. Let's consider this marker as square 1. Now if you draw this square, but you don't want to show this full length, then what you will do, you will draw perfect square, but this length you will add with the distorted dimension. And what would be that distorted dimension and angle? That dimension you can find over here. They are at 90 degree, but if you minus 90 minus 30, then actual it would be 60 degree only. So if you are drawing using the oblique projection, then your side would be at the 60 degree. Now orthographic projections. Orthographic projections are the flattened one view of the object onto the sheet of paper while retaining the correct proportions, that is angles and the dimensions. The orthographic projections best example is a top view, that is our map. If we are looking at any country's map, you will see that it is the representation of any sort of circular part. As we all know that our earth is a circular portion, but if we are drawing a map, we are not showing any sort of circular part. We are just simply flattening all the part, and we are just giving the total details, which includes the dimensions, which includes the angles, which includes the radiuses. All those details can be used in the orthographic projections. Apart from the maps, you can have the brief, any sort of brief drawing of any sort of isometric projections or any oblique projection. Likewise, if I want to have a total dimensional details of this marker, then I can have in this orthographic projections. If I am looking it from the top, then I can have the total length of this object as well as the width of the object. Okay. If I am looking from the front side, then what would be the thing? I will see the total height of the total length of the object as well as total height of the object. Now, if I am looking it from the side, what I will see? I will see a circular portion, that is the section of any sort of object, which means that in the isometric projection we can have a total 3D details of any sort of drawing, but in the orthographic projections you can have individual detail of each view. How it will look if we are drawing from the top side, how it will look if we are drawing from the front side, how it will look if we are drawing from the side. Apart from these three things, how it will look if we are seeing from the bottom side, how it will look if we are seeing from the rear side, right side, left side, front side, top side, bottom side and rear side. All these things can be drawn in the orthographic projections. Some are